folks, Mr. Slicing with the third learning activity of Unit 9, acid bases and salts. Third activity is entitled Neutralization Reactions and Electrolytes. Hopefully, if you watch the first two and perform the first two learning activities, 1 and 2, you're going to need some of that knowledge to help you understand the neutralization reaction electrolyte learning activity. Now, I have a couple learning targets for you for this learning activity. First one is you should be able to identify and predict the products of an acid-base neutralization reaction. We'll do that one first. And then second, we'll tie it in with being able to identify electrolytes. Now, I know you might have seen that term before back in Unit 7, but we're going to be using definitions of acids and bases that you had from the first learning activity of this unit, and the definition of salts to truly identify all electrolytes. Back in Unit 7, we did not identify all electrolytes. So first, neutralization reactions. What is a neutralization reaction? Well, by its name, it's a reaction between an acid and a base that produces water. Now, you should have gotten from the last learning activity number 2 about the pH scale that water, of course, is a pH of 7 or neutral. Now, that's where the name comes from. Now, the other product besides water is a salt. Now, salt is something that you might remember back from Unit 5. It's just a generic name for any ionic compound. That's all a salt is. Now, a neutralization reaction is also an example of a double replacement reaction. So as you're trying to predict the products of these, please keep in mind that the connection back to Unit 6 is that these are double replacement or double swap of the ions in the reactions. That might also help you. So generically, what they look like, it can be any acid, any base, doesn't matter. They're going to produce a salt that you're going to have to be able to predict what the formula is, and water, H2O. Now, a very common example would be the acid, hydrochloric acid, HCl, and the common base, sodium hydroxide. Now, I've color-coded the ions here to kind of help you think about what this double replacement reaction is. Now, these reactants, hydrochloric acid and sodium hydroxide, will react to produce the salt, table salt, sodium chloride. All right, so you can see that the Na comes from the base, and then the Cl comes from the acid. And then there's the water, also color-coded. You can see it's written as HOH to help you identify the double replacement aspect of these reactions. Of course, you can write water as H2O. Now, what's really happening at the molecular level? I got a quick little video as I quickly change screens here to kind of help you with this. So in this little animation, you're going to see this reaction in detail. All right, and just to help identify, so you're going to see these green, white, that's the acid HCl, and then the other substance, other reactant you see in here, the purple, the red, and the white, that's the base, sodium hydroxide. Now, first thing I want you to recognize is how they've broken down, they've broken apart. See how the hydroxide and the Na broke apart, and the H positive and the Cl negative are broken apart. That's the electrolyte aspect, and we're going to come back to that in just a moment. All right, so they've ionized. Now they're time to react. They're going to double replacement reaction. So now you're going to get the Na with the Cl. Okay, so there's the first product. All right, the NaCl. All right, and then the second product, if you watch this ion hydroxide here, boom, it just got an H positive. There's the water aspect. Okay, so that's what's happening at the molecular level. So get those two things together. Going to slow it down with the HCl and the NaOH. All right, showing that double ion swap, the ionization, and then the swap of the ions. H positive going with the hydroxide, and the Na positive going with the Cl negative. There you go. Now, moving on. Okay, so what you're going to have to do is be able to predict the products. So keeping that little video in mind, what are the products of these reactions? So first sample problem I have for you here is between the acid HNO3 and the base KOH. Now, of course, first thing you're going to want to do is write those two reactants down. Now, in this case, to help you, I've color-coded this, but you won't have to once you do a few of these. Now, the first product you should be able to recognize, neutral, is water. All right, so write out the HOH. And again, if you want to write it as H2O, that's fine. But here I'm just showing you the double replacement aspect. You get an H positive from the acid, HNO3, and then you see the OH negative of the base coming with that H positive. There's where the water is formed. And then the remaining substance, KNO3, comes from the remaining two ions. Now, K is positive and would always be written first. NO3 would be a negative ion, nitrate, and be written second, and that would be your salt. So just a reminder, salt is any ionic compound. Those are the ones that are between metals and non-metals, or of course a polyatomic ion. Now, second problem. So you can read it, take a moment, read it over. You got HCl, which of course would be an acid, and calcium hydroxide would be the base, or Arrhenius base. You can go by that definition you learned from the first learning activity. So you're going to write those two reactants down. Now, the only thing a little bit more difficult about this is every H positive of an acid has to be neutralized by a hydroxide OH negative of a base. In this base, you see that there are two hydroxides. So yeah, you can go ahead and neutralize one of the OHs, one of the hydroxides with the H positive that you have, but that only makes one water, and you still would have another hydroxide remaining. So what we're going to do is have to have another H positive, but you can't change the formula of HCl. That's the formula of the acid. But a little stoichiometry or balancing here. You can add 2 in front, which of course, all right, that increases the number of moles to 2. So now I have 2 H positives and 2 Cl negatives. So that would, on the product side, be able to form 2 waters to cancel out all the hydroxides. And again, you can just write it as 2H2O. Now, the remaining ions, of course, form the salt. In this case, you see the Ca, which would be a positive 2, group 2 ion, and the Cl negative 1. Now, remember, there are 2 of them when you put that 2 there, and that's going to be needed to form the correct formula of this salt, CaCl2. All right, so there you see the idea. Now, the next aspect is the idea that you saw when you were seeing these reactions take place. Acid, bases, and salts all together in this neutralization reaction, well, that makes up an electrolyte. Okay, so basically extending our understanding from Unit 7. An electrolyte, as we already know, is a compound that ionizes or breaks into ions in an aqueous solution, allows for the conductivity of electricity. So acid, bases, and salts all do this. So just as a quick refresher of what we're talking about, you probably may or may not have seen this back in Unit 7 solutions. All right, what do we mean? Well, here's some sodium chloride table salt. When it goes into water, all right, as an electrolyte, it breaks into its ions. The Na positive and the Cl negative don't stay together, as opposed to something that's a non-electrolyte like sucrose, all right, which is just a molecular substance. It goes in, it dissolves, but it doesn't break into its different ions. It's not ions, it's a molecular substance. All right, so at the water level view, okay, just to give you a further idea. So here's an NaCl, an ionic solid going in, all right, break it into its ions, and then you go to your sugar molecules. Well, they just stay as sugar molecules. Okay, they do not break into all the different ions like the NaCl did. So just a little fresher of what that means, that it ionizes in solutions. All right, so how are you going to be able to identify? Well, you've been working on the acid-base definition for the past 2 learning activities. So you also should recognize that you have in your periodic table, your state reference tables, the table K and table L of common acids and bases. So obviously, if it's on the acid table or the base table, they are electrolytes. All right, and the other thing you got to recognize is the salts. Now, that's more of a review concept, remembering that salts, ionic compounds from Unit 5 are also electrolytes. So here's a common question. All right, so how to identify an electrolyte? Well, look for an acid, base, or salt. That's the key. If you have any one of those 3, you have an electrolyte. So here's an example question. Which of the following substances is able to conduct electricity in an aqueous solution? So you look over those answers carefully. There's one that's in there that's a little tricky. All right, we'll talk about here at the end. Now, as I'm looking at this, there's an ionic compound, KCl, metal, group 1 metal, potassium, and a halogen nonmetal chloride. That's a salt, okay, potassium chloride. Now, the other 3 are non-electrolytes, molecular, all covalently bonded. All right, so answer 3, of course, would be the choice. Now, if you pick number 1, or you were thinking about number 1 because you saw an OH, yeah, that's a little tricky, okay? So the key is bases, all right, that you've been studying. If you pick number 1, or you were thinking about number 1 because you saw an OH, yeah, that's a little tricky, okay? So the key is bases, all right, that you've been studying from the first learning target are metal hydroxides. Those are your Arrhenius bases. If it's molecular with carbon, especially starting with carbon, and you see an OH, it's actually not a base. It's what we're going to see in Unit 11, an organic substance called an alcohol. So just be careful of those. Well, I hope that helps. There is, of quick little post assessment for you to do. So keep referring to this video, or if you look back at some notes to do that, please go ahead and finish up that post assessment.